G'day guys, Socket here. In today's tutorial we're going to be looking at Infinite Baffle. Now this topic was requested by Bernardo, who lives out in Spain and is one of our newest Patreon members. So Bernardo joined a few days ago along with Kai. I'd like to say a great big hello to both Kai and Bernardo, and welcome to the channel, guys. I hope you're enjoying it here and I hope you're enjoying the content. So Infinite Baffle, yep, it's something that's been around a long time and has been made pretty popular in recent times by Peter over at PS Sound. He loves Infinite Baffle, and and everybody's kind of caught the craze over the last couple of years. But what I thought I'd do is I'd explain a little bit about how Infinite Baffle works, the different types of Infinite Baffle, how you go about installing Infinite Baffle in your car, and most importantly looking at some of the RTAs, comparing Infinite Baffle installs versus the traditional enclosure types of installs. So I hope you get a lot out of today's video. Let's jump in and take a look. So when people think about Infinite Baffle, we often think about cutting big holes in our car and mounting the speakers so that they can breathe to the external environment. And while that is a form of Infinite Baffle, there are many different types. So for example, mounting your mid-range speakers on the dash is a form of Infinite Baffle. Mounting your subwoofers to a solid wall in behind the rear seats to separate the main cabin from the trunk, like I have in my BMW, is another form of Infinite Baffle. So there are lots of different types. So let me explain exactly what an Infinite Baffle mounting is. So let's have a talk about how a speaker and the sound waves actually operate. So here we have a speaker and it's playing, and here's the sound wave coming out of the front of the speaker, and we call this the front wave, right? But as the speaker moves in and out, it not only creates a front wave, but it also creates a back wave. So as the speaker pushes, it pushes the air this way, and when the speaker pulls back, the speaker cone pulls back, we create a back wave. And that's speaker in out, so it's creating this ripple of waves going this way and a ripple of waves going this way. But in reality, it's more like throwing a stone in a pond. We have sound waves forming a sphere. And as we know, the higher frequency drivers like tweeters and mids tend to beam, and the mid bass and subs tend to be omnidirectional, but they all produce this sphere of sound waves emanating from the speaker, right? So when we put these, when we put a speaker in an enclosure, we still get a front wave, we still get a back wave, but the difference is now the sound waves are enclosed in a box, right? So our side waves, for want of a better term, are largely, the energy from that is largely contained within the box. The back wave is largely contained within the box, and of course, within the box they're going to bounce off the surfaces and interact with each other and all of that, type of stuff. And but the net result is the pressure from the back wave is unable to escape. So it inevitably puts pressure on the cone, right, and restricts the movement of the free movement of the cone, by whatever the size of the box is. So the smaller the box, the more pressure on the cone, and all of this type of stuff. Now, sometimes when you're designing speakers or speaker boxes, you want to design a box a certain size, to actually put back pressure on the cone, right? To be able to control the cone's movement. But all enclosures have this feature, is that they apply back pressure to the cone and stop the cone completely moving as freely as possible, right? So that's an enclosure. With an Infinite Baffle, instead of being an enclosure, we are creating a baffle that is separating the front and the and the back wave, right? They are physically separated from each other and can't interact. But the thing with an Infinite Baffle, unlike an enclosure, is our back wave and our side waves are free to dissipate, right? There is no enclosure for the pressure to build up and to put back pressure on the cone. And as a result of that, it means that the cone can move back further and create bigger sound waves, right? Because it's physically moving back further and it's able to push more air. And so the main advantage of an infinite baffle is it produces lower frequency. It allows the speaker to play in lower parts of the frequency range than it otherwise would. The flip side is because there's no back pressure on the cone, you tend to find that there's less top end, right? So it kind of shifts all of the, not exactly right, but it kind of shifts all of the frequency range of a speaker a little bit lower, right? So now we've got a bit of an understanding of how the IB mounting process works, and it's really all about reducing or eliminating the back pressure on the speaker cone to allow the speaker to move freely. And when you think about it, this is the same problem when you put a speaker into a very small enclosure where it just simply is too small and you have so much pressure build up that it actually muffles or restricts the speaker movement considerably. Well, IB is completely the opposite. IB is about eliminating that back wave as much as possible so the speaker can freely move and is really only being controlled by the magnet and the physical properties of the speaker, and allowing this speaker to control its own movement as opposed to having back pressure having some influence on the speaker's performance. And there's a number of ways that we can achieve this. One of those is to cut a big hole in the car and mount the speaker so that the back wave can dissipate to atmosphere, and provided that you've got a hole somewhere between 30 and 50% of the cone area of the speaker, that's a sufficient size hole to allow the back wave to dissipate. But there are other ways to achieve the infinite baffle effect, and we've mentioned a couple of those already. One is putting your mids in a dash mounted arrangement so that the airspace underneath the dash allows the back wave from the mid-range speaker to dissipate, but it's still kind of separated from the front wave in the cabin of the car. And the cabin's acting like a huge enclosure, right? But the two waves are unable to cancel each other because the dash is acting like a barrier. But there's no back pressure on the mid-range speaker, and it can play freely. Another example, as we mentioned, was trunk IB, where you mount your subwoofers to the parcel shelf, or you create a wooden baffle, or a baffle between the rear seats to separate the cabin and the trunk of the car, and then you make that all airtight, and you'll mount your subwoofers in that in that baffle, and then the boot or the trunk of the car is acting like a great big enclosure. And depending on the size of your subwoofers, so if they're a pair of 12s, or in my case a pair of 15s, and the trunk has got enough venting to allow that pressure build up, not to get too great and affect the movement of the subwoofers, then once again they're free to move, without the influence of any back pressure. So I hope that kind of makes a little bit of sense about the two mounting methods, and why, for example, speakers sound muffled or don't sound well when they're in an enclosure with insufficient airspace, like mounting them in the door cards, and having the door skin of the vehicle, just way too close to the magnet, so that the speaker can't breathe at all. It kind of explains, why we get the IB effect, where we give complete freedom of movement to the speaker, and why going to the other end of the spectrum, when we muffle a speaker, why that has an effect on the how the speaker moves and the resulting sound. But let's go and have a quick look at the pros and cons of IB. So I think we've already touched on the first major advantage of installing speakers in IB, and that is the fact that the speaker is able to move freely and naturally, only being controlled by the magnet, the stiffness of the speaker, and the other physical characteristics of the speaker's design, free from the influence of the back pressure on the cone of the speaker itself. But That generally translates into a low-end extension of the speaker because the speaker is moving, I guess, more than it would with the back pressure applied to the back of the cone. And that is important for things like subs and mid-bass, less important for your mids. But it's not true to say that all speakers sound better in IB or all speakers need to be in IB to give you a low-end extension. That's not true at all. And so, for example, you can get super low-end extension with a sub in a enclosed box or an imported box. It really just depends on whether the box has been properly designed to suit the particular subwoofer that you're driving, or your box with a port is properly tuned for your selected subwoofer. In both of those cases, you can get extremely low extensions, just as low or lower than you can with IB. And when it comes to different speakers are designed for different roles, and there are speakers that are designed for IB applications and speakers that are designed for enclosed applications. Now you can chop and change them around, but they're designed to play in a certain way, and the key parameter that you're looking for when you're looking at your speaker specifications is QTS. So a QTS of 0.7 and above means that is a speaker that's designed for IB applications. A speaker with a QTS of 0.4, 0.3 and below is really designed for an enclosed application, and between the two values, 0.4 to 0.7, they're kind of in the middle and could be used for either. So that's the important parameter that you're looking for. So it's your mid-bass and your subwoofers that benefit the most from an IB installation. But let's just talk about each of those in turn, because just putting your sub into IB doesn't magically make all of the bass better. There are some trade-offs. So there is what we call true IB, where you are venting the speaker to the atmosphere, and then there is trunk IB and other forms of IB that we kind of talk about. But let's just talk about the subwoofers to start with. So when you have your subwoofer mounted in true IB, the main benefit is the speaker playing below 20 hertz, that low end extension. You tend to find that instead of it rolling off at 18 or 15 or 13 hertz or something like that, with the low end of the subwoofer starts to roll off, that will extend a certain amount, and it might roll off instead of at 18, it might start rolling off at 14, right, or something like that. And that is that's what people, when they put their subwoofers in true IB applications, where they cut a big hole in the floor of their trunk or their boot, and they seal the subwoofer off, and so the subwoofer is then sort of venting or playing through the floor of the trunk. Then you're able to get that really really lows. But the trade-off is that the middle bass or the upper bass tends to be lower as well, right? You don't get, it's not quite as musical. And so if you have a trunk IB application, yes, you won't get something playing down to maybe 13 hertz or something like that. It'll be close but not quite. You get a lower end extension with true IB subs, but your 60 to 100 hertz range will be far more musical than in a true IB application. So there are trade-offs, and it really depends on what you're looking for in your system. But as in, most people, want that super low, even though you really, in many cases you can't hear that. You tend to feel it more than you can hear it. But it's something that people, for some reason, want to chase the lowest notes that they can possibly play in their systems, and that's why true IB application for subwoofers are popular. So while we're talking about the subwoofers, the other major disadvantage is not everybody wants to go and cut a massive big hole in their car they're worried about safety, or they're worried about roadworthy, or registration issues. Also, when you mount your speakers in IB, generally you tend to lose your trunk and your boot space. So once again, these are those kind of decisions that you need to sort of weigh up when you're determining whether you want to do true IB, in a trunk with your subwoofer, or whether you want to go with something like a trunk IB arrangement, or a sub in an enclosure. These are all things that you need to consider. So now that we've talked about subs, let's turn our attention to the mid bass. Now, 75 to 80% of the builds that I've seen have the mid bass built into the doors, either mounted on the door cards or screwed onto the door frame, generally venting into the void between the door skin, the metal skin of the door, and the door card itself. Now, the major problems with door mounting, even though they're convenient, they're out of the way, and a lot of OEM manufacturers sort of put them there. The major disadvantages is, first of all, there are wires and window mechanisms and glass and and all of this other type of stuff, and no matter how well you sound treat the doors, they will always rattle. The second major problem is, unless you've built custom enclosures into your doors, it's impossible to get an airtight seal between around the door card and all that type of thing, so they tend to leak air. The magnets are then in the void, generally sticking into the void of the door, and water is, the doors are designed for water to sort of when it rains, to sort of flow through the inside of the door itself and then sort of drain out of drain holes at the bottom of the door. So the magnets are exposed to water and moisture without a lot of protection. And we talked about the airflow and that type of thing. So there's a whole bunch of inherent problems with mounting speakers into door cards. But you can get a decent result with having your mid bass there, with enough work, right? But mounting your mid bass in IB or true IB, either by cutting holes under your seats and then bolting the speakers to the floor, or cutting holes in the kicks of your vehicle, and then making a mounting ring and bolting the speaker directly to the metal body of the car. I mean, the biggest advantage is, first of all, you get a super solid mounting. Secondly, they're generally nothing to rattle, right? The speakers are bolted to the car body, and if your car body is flexing, then you got more problems than your speaker response. So the main advantage is being able to get a super solid mounting. The disadvantages, and let's talk about under seat versus kick IB applications. So the major problem with putting the speakers underneath your seats, number one, is clearance. So do you have enough clearance to sort of get your speaker underneath the seats, so the seats can freely move back and forth. The second one is, generally you're going to find that your speaker magnet is going to sort of extend beyond the floor of the car, and be very close. If you've got, for example, a car under tray, a plastic under tray or something like that that covers the bottom of the car, you're going to have to somehow chock that up to allow the speaker to breathe between the under tray and the body of the car itself. So that can cause rattles and things with your under tray. But you're going to have to somehow treat the outside of the speaker so that it doesn't get wet, and we'll talk about that a little bit later. The other major disadvantage of under seat IB applications is generally they're firing, or not generally, but they will be firing into the bottom of the seat, and that then limits the upper range that you can get from your mid bass. So generally under seat locations won't play higher than about 150 hertz, just because they're being absorbed by the seat material itself. Now, when it comes to IBs in the kicks, it has its own challenges. Often there'll be wiring and fuse boxes and other things that need to be relocated so that you've got a clear area to cut through. Often there are drains and things for your sunroofs, pipes and other structural elements, so that you need to be careful where you're cutting through. Often it's just not a single layer of metal. It's usually 3 or 4 layers of metal. Sometimes there's foam and other materials making it difficult to cut through. It's a tough job to do, to actually cut holes in your kicks. And once again, people are concerned about safety or registration issues or other things like that. And of course, you need to be conscious of being able to treat the outside of the speaker so that water doesn't get into the cabin. And you've got other problems, particularly if you've got the magnets sort of pointing out into the wheel wells in terms of clearance with your liners inside your wheels and things like that. So yeah, look, both locations have their own installation challenges, but the big advantage, as I said, of IB application is solid mounting, lack of rattles, and in relation to the kicks, there's also an advantage in terms of path length. The distances from the mid bass to the driver tends to be fairly equal, which means making tuning a lot easier, and you tend not to have those cancellations, around 120 or 150 that you find when you have mid bass speakers firing into the center console and causing physical distance related cancellation. So there are benefits in terms of tuning by having your mid bass set in IB in the kicks as well. So if you're not afraid of cutting holes in your car, in my opinion, installing your mid bass in true IB and the kicks is the ideal location for mid bass, mainly because the mounting is solid. There's no vibrations, there's no rattles. The speakers have great path length between their locations and the listening position, which means that there's very few cancellations, and they're easy to tune and integrate with the sub. For me, that's the ideal locations for mid bass, but not everybody wants to cut up their vehicle, right? So in the 3 builds that I've got at the moment, my little Audi A1, the wife's Audi A4 and the BMW, the only one that I haven't put the mid bass in the kicks is the wife's Audi A4, because she wouldn't let me cut up the car. But let's go out and have a look at the little Audi A1, and I'll show you how mid bass installed in IB in the kicks is kind of set up, and how to protect the speakers using a product called Rainguard. Okay, let's take a little look at this IB setup in the little Audi. So the easiest one to get to is over here, and it's just tucked in behind the sub box. So you can kind of see the speaker mounting ring. Well, you can see the metal of the floor under here. Then there's the mounting ring, and then the speaker's basically bolted straight onto there, and of course backfiring into the cabin. So and that's just a hole cut straight through the metal, and then of course around the other side, we'll just have a quick look. Down in here, and you might just be able to see the vent where it's breathing out. Okay, so that's been in place for a little while now, a few years. So I'll see if I can get that in focus. Maybe not, because the tyres in the way. But so that just has a layer of rain guard, and nothing's got into the cabin, even though the wheels are sort of throwing water and dirt into the vent area. So let's go and have a look at the rain guard itself. Okay, well this is the magic rain guard. I'll just put it down here so we can see it. So as you can tell, it's a open cell foam. You can see my hand through it. So it's acoustically transparent, meaning that sound will go through it, no problems. It's relatively thick. It's probably 3 mil thick, something like that. And and compression is pretty easy. Like, you can squash it down, no problems. And it's got a bit of a waxy, slightly oily feel to it. But basically, you sandwich this between two, slim mounting rings, as just shown the pictures, and you sort of fit that between the opening, the outside area of the car, and the speaker magnet or the speaker cone, depending on which way you're facing your speakers. But yeah, it's with a layer of that between the speaker and the outside of your car, nothing gets in, dust, water, or anything like that. It's amazing stuff. I'm not too sure where to get it from. Peter sent me this a couple of years ago, and this is all I've got left. But if you find a supplier, please let me know. Yeah, I'll see if I can find a bit more about it, and maybe put, if I find a link or something, I'll put it down in the description for you guys. All right, there you go. That is called Rain Guard.
So all of that's great, but at the end of the day, how do speakers respond differently from when they're installed in the doors compared to when they're installed in the kicks in True IB? So I just happen to have some measurements of my focal 6.5 inch, which were originally installed in the door cards on by BMW. I then relocated them to True IB in the kicks, and so let's have a look at the before and after measures. So first off, guys, apologies for the poor quality graphics. This is a screenshot of a screenshot of a screenshot of my measurements back from 2022. But I'll try to explain what's going on here, even if you can't see them particularly well. So here in blue are the focal 6.5s in the doors. They were kind of playing up to about 90 hertz and then rolling off, and at the other end, through to a bit over 200 and kind of rolling off. But you can see, yeah. Anyway, that's the shape. And then with the when we move them to the kicks, in True IB, this is in the red. So the very first thing you can see, we've got a lot more low extension. So instead of rolling off around, that 70 mark or whatever, we're now rolling off at about 40. And on the top end, it's still rolling off around 200. But we've got a lot more level, and the speakers are playing a lot cleaner. They haven't got these huge dips and peaks and things going on that we've found in the doors, right? And this is partly a function because we're giving the speakers now more airspace and to breathe, and being a high QTS speaker, they're able to play in a controlled manner, right? So looking at the measurements in the kicks, this is what the full range measurement looked like. There's a tiny little dip here at 157, no big deal. On the other side, a tiny little dip at 100, but super easy to do the EQ work, no problems at all. And at the end of the day, just showing how they both EQ'd, haven't level matched them yet, but yeah. Just a beautiful playing pair of mid-bass. So there you go, guys. That brings us to the end of today's Infinite Baffle tutorial. I hope you found that interesting. And as I indicated during the video, if you put something into IB, it doesn't automatically mean it's going to sound better. It does depend on your choice of speakers. Not everybody wants to cut up their car, and all of that type of stuff. But at least I hope this video has explained to you what IB is, how it kind of works, the types of trade-offs that you might need to consider if you're thinking about going down this route, and the types of results you can kind of expect. But as always, if you've got more questions, guys, just let me know and I'll do my best to cover them off for you. Otherwise, once again, I'll catch you in the next episode.